numerical solution of equations. It involves reciprocal. So the cosecant graph and the exponential graph. So to show that the equation cosecant 1/2 x equals e to the x minus 3 has exactly one root, we need to draw two graphs on the same set of axes. So we have to draw y equals cosecant 1/2 x and y equals e to the x minus 3. To draw the cosecant 1/2 x, maybe just start with this. If you remember the basic graph y equals sine x, and for 1 over sine x, so cosecant is actually 1 over sine, we have to use 1 over all the y values. So when the y value here is 0, 1 over 0 is undefined or it's infinity, so we have an asymptote basically. So when we draw a reciprocal 1 over this graph, the x-intercept becomes a vertical asymptote. So we have vertical asymptote here, vertical asymptote here, vertical asymptote here. And when the y is 1, on the top here the y value is 1, so it is still 1 because 1 over 1 is also 1. Okay, so this is the graph, and now approaching asymptote, approaching asymptote, approaching asymptote, approaching asymptote, we have this graph. And for the cosecant 1/2 x, we have to use transformation. This is a horizontal stretch about the y-axis, so this is the center of the stretch. So for horizontal stretch, 1/2 means we stretch the stretch factor is 2, not 1 over 2 but 2, which means we stretch this graph in this direction twice as big. Okay, so this is the kind of graph we get. We have to draw from 0 to pi only, so we only need this part later. Now for the e to the x minus 3, this is the basic shape of e to the x. We have a horizontal asymptote x-axis and the y-intercept 1. So for this transformation, this is a translation, so we slide the whole graph 3 units downwards, which means the horizontal asymptote becomes minus 3, y equals minus 3, and the y-intercept becomes 1 minus 3 is minus 2. So this is the graph. So if we draw this, we for the blue cosecant graph, this is the part we draw. So this point is pi minus 1. We have to label the pi and minus 1, and it's supposed to be approaching asymptote. And this green graph now, so for the green graph, actually this value is minus 2, so you have to label this y-intercept minus 2, and the shape is like this. So we draw the shape, and we have only one intersection, so you have to state that we have only one intersection, which means we have only one root, which means we have proven that we have only one solution, one root. Right, now the next part, verify by calculation that alpha lies between. So alpha is the root of this equation. So from this equation, just move everything to the left or to the right. Here, if you move everything to the right, so subtract cosecant 1/2 x from both sides, you get this expression to check or to verify. So you replace the x with 1 and then 2, and you should get something positive, something negative. And if you don't have cosecant in the calculator, just use 1 over sine. So like this, 1 over sine for cosecant. So you should get this. Of course, we use radians. In numerical solution of equations, we always use radians. So since we have something negative, something positive, draw the conclusion. Sign change exists, therefore alpha lies between. So just copy this part from the question, alpha lies between. Next part, show that if the sequence of values in the interval given by converges, it converges to alpha. So basically you have to do the algebra. So turn this equation here into the original equation in the first part. We start by ignoring the subscripts n plus 1 and n. So just rewrite without the subscripts, and then so you get this, and then we do e to the power of both sides, because on the right you cancel out. We have only e to the x equals the argument of the logarithm, and then we subtract 3 from both sides, and we get the equation in the first part. So this is proven, only 1 mark for this. And the last part, iteration. So we use this iteration formula from the part C. So for the first value you can use 1.5. So this 1.5 is because previously we have verified that the root lies between 1 and 2. So just use the average. 1 plus 2 all over 2, we get 1.5. So this is the average of the two verified values in part B. Okay, so use a calculator. Again, for the cosecant we use 1 over sine for the cosecant. So if you use your calculator, you get this. Of course we have to use radians, and for the next calculation, you just go back in your calculator, replace the 1.5 with the answer button. So we use the answer button like this, and then use calculator for the whole thing, and you get this value. After that, just press the equal sign, you get this value. Equal sign again, you get this value. Now if you round off to 2 decimal places, here you already have 1.5, and here you get also 1.5, 1.5, 1.5. So the alpha is therefore 1.5. And for the last part, state the minimum number of calculated iterations and correct to 2 decimal places. So how many iterations should we do to be certain that we get the answer correct to 2 decimal places? So there will be 4, because we always get exactly the same values, and if you look at this, exactly the same in 1, 2, 3, in 5 dp. So of course there's no need to continue, so we have the certain answer 1.50. Alright, so 4 times at least. Okay, I'll see you again next